All right, we got two more, 8, 9, and 8, 10. We're almost there. So 8, 9 deals with real numbers and Pythagorean theorem. Real numbers, very interesting for square roots. Let's talk about square roots. Many students just memorize square roots. Square root of 1 equals 1. The square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 equals 4. Square root of 25 equals 5. Square root of 36 equals 6. Square root of 49 equals 7. The square root of 64 equals 8. The square root of 81 equals 9. Square root of 100 equals 10. Square root of 121 equals 11. And the square root of 144 equals 12. Those are the top square roots. Let's talk about why these square roots equal. We call it a square root because there's an invisible 2 in there. And so when we talk about inverses, or what gets rid of addition, subtraction, what gets rid of subtraction, addition, what gets rid of multiplication, division, what gets rid of division, multiplication, what gets rid of a square root is a square. So if I can write 4 as a square, we can write that as 2 times 2, and then we get the square root. 2 times 2 can be written as 2 squared. So this square and the square root cancel, leaving us with the 2. That's why the square root of 4 equals 2, because we get rid of this square root with the square inside. So each of these numbers, 1, 4, 9, 16, 25, 36, 60, 49, 64, those are called perfect squares because we can write them as a square of a number, and that cancels it out. So 256 is not one that a lot of students remember. And I think it might be, what's it, 256? Is it 16? It's either 13 or, no, it can't be 13. 16 times 16. It's 36. That is 9. That is 6. That is 1, 6, 5, 256. Is that my number? 256? Yeah. So square root. So this can be written, again, there is an invisible 2 in there. Let's write it with the 2. We can write 256 as 16 times 16. And 16 times 16 can be written as 16 squared. The square and the square root will now cancel, leaving us with 16. Find the square root. This says the opposite of the square root of 1/9. So when we get square roots, if they're multiplying or dividing, we can write them with their own square roots. We can separate them. So the square root of 1 is a perfect square. The square root of 9 is a perfect square. So we get -1/3. You can separate multiplication and division. You cannot separate radicals being added and subtracted. 1.44, that is a plus or minus sign. That's a very important sign. So this means plus square root of 1.44 and minus the square root of 1.44, which gives us plus 1.2 and minus 1.2. Plus or minus 1.2. And well, you notice that we see the digits 144. So the digit, the place, the decimal doesn't really affect the number, whether it's a perfect square or not. All right, we're going to simplify this first. So we actually can do inside, instead of separating them, even though they're both perfect squares, we could separate it to rad 81 over rad 9. But let's simplify that. That just equals the square root of 9. Square root of 9 equals 3. 3 minus 7 is -4. That's the most efficient way to do it. That's how I would do it. Square root of 121 is a perfect square. That's 11, which makes negative 12. Here's a great one. So this square root and square will cancel, giving us 5 plus 6, which equals 11. Yeah, instead of doing rad 6 times rad 6, which makes rad 36, which makes 6, this is just way more efficient. 2r squared equals 162. This is a good one. So we want to get the variable by itself. Didn't want to do that. I just wanted to erase that little mark there. So we got to get the variable by itself. Let's get rid of the things being multiplied, leaving us with r squared equals. That equals 81. Now I want to get my variable by itself. It's being squared. So I have to take the square root. Let's do this. Let's draw that. So what gets rid of a square is a square root. So we will take the square root. And what we do to one side, we have to do to the other. So we're going to take the square root of 81 also. And whenever you take the square root of a variable being squared, we have to introduce this plus or minus. And because any number, any negative number squared is going to give us the same as a positive number squared. The square and the square root cancel, leaving us with r. Plus or minus square root of 81 is a perfect square. That equals 9. So my value for r can be plus 9 and negative 9, or plus or minus 9. That's the notation here that you'll see. Solve the equation. Again, we're going to isolate the variable. We will get rid of addition and subtraction first. We get d squared equals 36. We're going to take the square root of both sides. When we take the square root of a variable being squared, we have to do plus or minus. The square and the square root cancel, leaving us with d. Plus or minus 30 rad 36. Square root of 36 is a perfect square, so we get 6 and negative 6. We'll do it again. We'll continue with square roots, isolating the variable. So we'll get rid of addition and subtraction first by adding 385. That's a negative. So we got 385 and 42. That gives us 3. That gives us 4. 343. 343 positive, because we have more positives, equals 7b squared. Let's divide by 7. 7 goes into 7 times 4, 28, right? Yeah, 28. So 4, 28. 28 gives us 63. 7 goes into 63 9 times. And now we're going to take the square root of both sides. Square root. Square root. Whenever we take the square root of a variable being canceled or being squared, we have to do plus or minus. Plus or minus 7 equals b. So we get 7 and negative 7. Just checking my answers, making sure that I'm correct. That is correct. Your distance, d in miles, from the horizon can be approximated by d equals 1.22 times the square root of h, where h is your eye level in feet above the ground level. What is your eye level when you are 9.76 miles from the horizon? Okay, so the distance. So we're going to plug it in for d. 9.76 equals 1.22 times the square root of h. We're going to divide by 1.22. Divide by 1.22. I'm going to throw that in the calculator. 9.76. Whoops. C 9.76 divided by 1.22 gives us 8. I like that. 8. Nope, not that color. 8 equals the square root of h. Now this time we have to get rid of the square root. What gets rid of a square root? A square. So we're going to square both sides. That gives us 64 equals h. These cancel. Square cancels the square root, leaving us. So we are 64 feet, not in red, 64 feet from the horizon. The speed s in meters per second of a tsunami can be modeled by the function s equals the square root of 9.8 times d, where d is the water depth. What is the speed of a tsunami when the water depth is 500? So we're going to plug that in for d. So s equals 9.8 times 500. D is in meters. We're given in meters. So S equals the square root. 9.8 times 500. 9.8 times 500 gives us 4,900. So 4,900. We see that 49 is a perfect square. So we can actually separate that to 49 times 100. And now we're going to separate each radical. Remember, we can separate radicals being multiplied. And square root of 49 is 7. Square root of 100 is 10. So it is 70. So it is 70 meters per second. 70 meters per second. What happens to the speed of the tsunami as the depth increases? As the depth increases, the speed increases. Yeah, speed also increases, because if you do 1,000, that's just going to make a bigger number in here, and it's going to produce a bigger number out there. So depth, as the depth increases, so does the speed. That's kind of scary. Evaluate the expression. We've done these. We did this very similar. Since these have like base 10s, we can just add these two. So we get 4.3 plus 2.4, which gives us 6.7 times 10 to the third. Write your answer in scientific notation, and that's good. Where students make their mistake is they add these exponents. Since we're adding, not multiplying, we just keep the base 10. We're going to subtract. These are not the same, so we're either going to make them both to the -2 or to the -3. I'll make this to the -2, and so if we make that bigger, we're going to make this smaller. So this becomes, right? I made that bigger. So that's smaller. Yes, that's good. Minus 1.5 times 10 to the -2. Now they have the same negatives. So we'll do 1.5 minus 0.35. Add a 0. That's 4, 5, 1. 1.15 times 10 to the -2 would be my answer. Yep, that's correct. Evaluate the expression. So we can do this. This is all just multiplication. 9 times 7 is 63 times 10 to the -2. This is not in scientific notation, so I have to take this decimal point and make it one place to the left. So that becomes 6.3 times 10 to the -1, because I made something bigger or smaller. So as I decrease this, I have to increase that. That is increasing. -2 to -1 is increasing in size. So we get the answer 6.3 times 10 to the negative 1. That's good. Evaluate the expression. Write your answer in scientific notation. We're dividing. So now we're going to divide these, and we're going to divide or subtract those bases. So 6.1 divided by 1.1 is just like 66 divided by 11, which gives us 6 times 10 to the negative 5 minus 4. There's the division, which is subtraction, and that gives us 6 times 10 to the negative 9th is our answer. Look how efficient we can be with these. All right, let's make this a little bit smaller. Identify any outliers. What are we graphing? Okay. Oh, actually, I kind of would like that. Let's make this smaller. That, oh, I didn't mean to do that. Let's make this smaller, but this bigger. And we can move this over here so we get a little bit more size. All right, let's graph those. Let's slide it over a little bit more. And let's plot these points. So 1, length is our x value. Yep. What weight is our y value. We get 1, 4. So 1, 4. There's a point. We get 8, 33. 8. And let's go up to 33. 32. 32 is right there. So this is 33. We did 3.5, 17, 3.5, 17. So 16, 17 right there. 2, 8. 2 and 8 is right there. 2.59, 2.59. 3, 9. Same place. 2.58. Oh, that's interesting. 2.58. We get 2.5s. You get 2.510. Oh, goodness. 8, 9, 10. There's a clump right there. And 3, 11. I can hear that. 936. 936. That's not me doing my hair. That's my lovely wife waiting for me to do a video to finally do her hair. All right. Which one's the outliers? Identify any outliers, gaps, or clusters. All right. Well, I see a cluster. I'm going to say a cluster is right here. Here is a cluster. So that would be really my only thing. Doesn't really have an answer. That's it. That's a cluster. That's the only thing we had to do. Okay. Make a scatter plot. New data. Let's shrink that up a little bit. I can count the number of times my wife has blow dried her hair at 12:54 on one hand. That's today. She's picking to do it today. Thank you. Love you. All right, let's do this graph. Even with the noise. All right, that's 1.5 right there. Okay. Maybe let's move it up a little bit. There you go. Oh, it's a different proportion. That's why. I'm all flummoxed with this. Let's do this instead of using the pen. That looks, well, let's stretch a little bit. Okay, that looks good. Let's put that back at 1.5. Whoa. Okay, I don't think we're going to be perfect. So 0.25 and cost volume. Always check your X's and Y's. So 1/4, 90. So 1/4, 90. 1/4, 90th. So that's 1. So that's, well, don't want that. Quarter and 0.09. 1, 3.9. 1, 3.9. Just right there. 1, 3.8, which is right there. Half, 5.5. Half, 5.5. Ooh, that's a weird one. Okay. 0.125. 0.125. And half. Okay, so that goes here. And 1, 4.1. 1, 4.1. That's right here. And half 2. Half 2. And 1, 4. 1, 4. Okay, so now outliers, gaps, clusters. All right, so let's talk about the easy one to see is the cluster. This is a cluster. So we got a cluster. We have an outlier now. So this is going to be our outlier. And gap, I mean, technically, could that be considered a gap in here? Maybe. Yeah, I mean, there are no values in between there. So that would be my answers. All right. 18. Find the side length S of a square. Well, we know that area equals S squared. So if the area equals 441 equals S squared, and we're going to solve for S, so we got to get rid of that square. So we're going to take the square root of both sides. Whenever you take the square root of a variable being canceled, we have to do plus or minus. So we get plus or minus 21 equals S. Now that means positive 21 and negative 21. But this gets negated because you can't have negative distance. You can't have negative 21 centimeters. So the answer is going to be 21 centimeters is the side length of the square. 19. I could totally hear it. Find the side length of the square. Again, here's my area. So area equals S squared. 1.69 equals S squared. We're going to take the square root of both sides. Square root, plus or minus. We get plus or minus 1.3. 1.3 equals S. Let's look. I think 13 squared is 169. 13 squared equals 169. So that's going to be 1.3. And that means positive 1.3 and negative 1.3. The negative 1.3 gets negated because we're dealing with length. And so the answer is 1.3 kilometers. Find the side length of S, the area. Ooh, all right. So we get 36/49. Area equals S squared equals S squared. So I'm going to take the square root of both sides. Square root, plus or minus. Now remember, when we multiply or divide, I can separate those into their own square roots. Why? And these cancel, leaving me with S, because I see that they're both perfect squares. Square root of 36 is 6. Square root of 49 is going to be 7, equals 7, equals my side length. That means positive 6/7 and negative 6/7. The negative is canceled because we're dealing with distance. So you get 6/7 yards. Yes, love it. How good. Those are good questions. I like that. And that's it. That should be all the answers. Yep, those are the answers for us. All right. Hopefully you did well on that. That was some more advanced stuff.